they can express the overall logical structure of the database graphically. Means if we want to show the database design or the database graphically, then we can use ER diagrams. Then ER diagrams are very simple diagrams and clear diagrams. Means with the help of that ER diagram, we can clearly identify what are the different tables, what are the attributes in that table, and what is the relationship between the two entities or the two tables, etc. So we can clearly identify such things from the ER diagram. Okay, then in the ER diagram, the very first point is the basic structure of the ER diagram. So in the ER diagram, the entity and the entity set is represented with the help of rectangle. Means this rectangle is nothing but the entity set. So here instructor is one entity set and student is another entity set. And the ID, name, salary, ID, name, total credit, these are the attributes of this entity set. Means the entity set is represented by the rectangle, and at the top of the rectangle we can declare or we can give the name of that entity set, and then below that we can give the attributes of the entity sets. Okay, and here the underline indicates the primary key attribute. Means in the entity set, suppose one of the attribute is the primary key attribute, then we can represent it with the help of underline to that primary key attribute. Okay, so simply the primary key attribute is nothing but with that attribute we can uniquely identify our data, or we can differentiate between our data. And one more thing about the primary key is that the primary key attribute does not allow the same value for a single attribute. Means what? If we consider here the ID for the student, then it should be different ID for different students or for every student. Okay, so it should not be possible that the same roll number or the same ID is allocated to two different students. Okay, so such things or such cases are not happen. But if we use the primary key, then the values for that primary key attribute must be different or must be unique. Okay, so like this way we represent the entity sets. Then relationship set. So how to represent the relationship set? So the relationship sets are represented with the help of diamond symbol between the two entity sets. Okay, so here the relationship between the instructor and the student is the advisor. So we can give or we can write the name of the relationship inside the diamond symbol, and with this diamond symbol the two entities are connected. Okay, so the relationship set, it is represented with the help of diamond symbol. Now next, the relationship set with the attributes. Means if the relationship set is having its own attribute, then it is represented like this. Means we can just give the name of the attribute and we can connect that attribute and the relationship set with the help of dotted line or with the help of dashed line. Okay, means this date is the attribute for the relationship set advisor, and this date attribute is called as the descriptive attribute, because we know that the attribute with the relationship set, it is called as the descriptive attribute, and it is represented with the help of a small rectangle, and that attribute is connected with the relationship set with the help of dashed lines. Okay, now next one is the representation of the role. Okay, so we know that the role is nothing but the function performed by the entity set is nothing but the role, or simply we can say that the label given to the line, it is called as the role. Now here the entity set of the relationship need not be distinct. Each occurrence of the entity set plays a role in the relationship. Means every entity set, he plays some function or some role in the relationship. So the labels course ID and the prerequisite ID are called as the role. Means this course relationship, it gives, we can say it gives the course ID to the prerequisite, and again if here is another entity like the prerequisite or prerequisite course, then again we can use the prerequisite ID to describe that particular connection. Okay, so the simply role is nothing but the different function or the operation performed by every entity is called as the role in the entity set, and it is represented by just giving label to the connection between relationship set and the entity set. Now, the next is the mapping cardinality constraints. Okay, so we know that there are total 4 mapping cardinalities: one to one, one to many to one, and many to many. So we can represent such mapping cardinalities with the help of in the ER diagrams. So we express the cardinality constants by drawing either a directed line. Okay, so this directed line, or simply we can say arrow, is nothing but the one. Okay, so in one-to-one relationship, if we have drawn this arrow, then this arrow is nothing but it is the one-to-one relationship. Or the undirected line means simply line. So this undirected line, it specifies the many part of the relationship. Okay, so this one-to-one relationship between the instructor and the student. Okay, so we have seen the one-to-one relationship between instructor and the student. So here the student is associated with at most one instructor via the relationship advisor, and the student is again the associated with at most one department via the student department. Means if again the department entity set is there, and between student and the department, if the student department is the relationship, then again we can represent it with the one to one. So here for every student at most one instructor is there, means one student and one instructor. So here we can represent it with the arrow or the directed line between the relationship set and that particular entity set. Okay, so if one, or we can say if the one-to-one relationship is there, then we can represent it with the help of directed line. If the many relationship is there, then we can represent it with the help of undirected line. So here one-to-many relationship. So the one-to-many relationship between the instructor and the student is that the instructor is associated with several students via the advisor. Means example of the project here. So here one project guide or the one instructor is dealing with 4 to 5 students or the number of students. So it is the one-to-many relationship. So it is represented as arrow line or the arrow symbol attached to the instructor. Means it shows that only one instructor, and the what we can say simple line or the undirected line, it is attached to the student. Means it says the number of students. So the one-to-many relationship is represented with like this. Then many to one, it is exactly opposite of the one-to-many. So the many to one relationship between again instructor and the student is that an instructor is associated with at most one student via again the advisor. Okay, means here the instructor is associated with only one student, or we can say that the many instructors are associated with one student. Means our guide and co-guide concept. Okay, main guide and the co-guide concept. So they the two instructors or the two guides, they can interact with the single student. So we can represent it with the help of many to one relationship. And The last one is many to many relationship. So here the instructor is associated with several students via the advisor, means the guide and co-guide can interact with group of students or can interact with the multiple students. So it is represented with undirected lines. Okay. So in the ER diagram, if the case is that where we have to show the cardinality or the relationship between the entity sets, then we can use one of them, means either we can use one to one. If the one to one relationship is there, then we can use the directed line attached to two entity sets. If the one to many relationship is there, then the directed line attached with the one entity set and the undirected line attached with the many side of the entity set. And if many to many relationship is there, then we can directly add the undirected line between the two entity sets. Then the next one is the total and the partial participation. Okay, so the total and partial participation, it is also part of relationship or the mapping cardinality. So the total participation, it is indicated by the double line between the entity set and the relationship set. Okay, so total participation means the every entity in the entity set participates in at least one relationship in the relationship set, then it is called as the total participation. Okay, means here the total participation is between advisor and the student. Means what? Every student in that college or every student in that class is participating in the relationship set advisor. Means what? The participation of the student in the advisor relation is the total, because the every student must have an associated instructor. Okay, so it is the case that for every student there must be one instructor, means all the students in the entity set student, they are participating in the relationship. So here the participation is the total participation, or we call it as a total participation. And partial participation means what? So partial participation is nothing but the some entities may not participate in called as a partial participation. Some of the entities are participating in the relationship set and some entities are not participating in the relationship set, then it is called as the partial participation. Example is that the participation of the instructor in the advisor is the partial, because we can say that only one instructor is sufficient for a group of students, means consider the 10 students. Okay, so only one instructor in that instructor table or in that instructor entity, so only one instructor is sufficient for the 10 students, means consider here total 5 instructors are there. Okay, so among that 5 instructors, we are using only one instructor to guide 10 students. So here the instructor's participation is the partial participation, but the students' participation is the total participation, because all 10 students are participating in the relation, or all 10 students have at least one instructor, means what? It is the total participation. Understood the difference between total participation and the partial participation. Okay, if the total participation is there, then we can represent it with the double line. Okay, and this double line is attached to the entity set and the relationship set. Okay, the entity set means which entity set? So where all the members of that entity set are participating in the relation. So it is called as the total and the partial participation. Now, next representation is the complex constraints. Okay, So the complex constraints are represented with the help of some numbers, either L, H. Okay, L is nothing but the minimum and the H is nothing but the maximum cardinality. Okay, means this mapping cardinality, it may be low or it may be high, minimum or the maximum. So these complex constraints are represented by a line. uh, so the line have the associated minimum and the maximum cardinality. Okay, and this cardinality is in the form of low to high, L to H, etc. Then the minimum value of 1 indicates the total participation. Okay, means instead of drawing the double line to represent the total participation, then we can write the minimum value 1, means value for L is the 1, so it is nothing but the total participation, and the maximum value of 1 indicates that the entity participates in at most one relationship. Okay, if the maximum value of the 1 is there, then it indicates that the particular entity is participates in at most one relationship, means maximum one relationship. If the minimum value is the 1, then we can say that it is the total participation, and if the maximum value is the 1, then we can say that that particular entity participate in maximum one relationship. Okay, and the maximum value of star indicates no limit. Okay, so if we are given the h value as a star, means what? There is a no limit, means the n number of entities in the entity sets, they participate in the relationship set. Okay, so these complex constraints or the complex cardinality, it is represented by L and H. Okay, L means the minimum value and the H means the maximum value. Then it is the notation to express entity with the complex attributes. Okay, we have seen that the types of attributes, means the simple attribute, composite attribute, then multi-valued, single-valued. Okay, so these all kinds of attributes we can represent in the entity sets. So here the instructor is my entity set, or it is the name of the entity. This id is my simple attribute. Okay, so and the id is the primary key of the instructor. So here I have just written id and underline to that attribute. Then name attribute, it is my composite attribute. So here the name is divided into first name, middle name and the last name. Okay, and again the address is again divided into street, city, state and zip. Okay, means if the particular attribute is the composite attribute, and if we are giving the components of that composite attribute, then we can write like this, means like a hierarchy we can write the component attribute. Okay, so here first name, middle name, last name, these are the components of the composite attribute name. So we have written like this, like in a hierarchy we can write this. Then the phone number attribute is the multi-valued attribute. So the phone number attribute or the multi-valued attribute, it is right in the curly bracket. Okay, if any multi-valued attribute is there, then we can write it in a curly bracket. Then date of birth, and the next one is the age. Okay, as we know that the age is our derived attribute, so we can write as the name of the attribute and the brackets. Okay, means like we write the function. Okay, so we can write age and the blank brackets. So it is nothing but it is the derived attribute. Understood? So the complex attributes are represented like this, means if the simple attribute is there, then we can write just name of that simple attribute. Then if the attribute is the composite attribute, then we can write name of the composite attribute and the names of its components. If the attribute is the multi-valued attribute, then we can write in a curly bracket. And if the attribute is the derived attribute, then we can write as a function, means name of the attribute and the brackets. Okay, so these are the some ER notations which are used to draw ER diagrams. So simply the entity set, if only the entity set is there, then we can represent it with the help of a simple rectangle. Then the relationship set, it is represented with the help of diamond symbol. Then this double diamond means what? Identifying relationship set for the weak entity set. Okay, so we will see it later. Then the double line between the relationship set and the entity set is nothing but the total participation of the entity set. Then if we want to show the attributes in the attributes of the entity set, then we can represent it like this. So here A1, A2, and again the A2 is having subparts. So A2.1, A2.3 means A2.1, A2.2, these are the composite attribute. A3 is the multi-valued attribute and A4 is the derived attribute. Then if the attribute is having the primary key, then we can represent it with the help of underline to that attribute. And again, this is the attribute for the weak entity set. So we can represent it with the help of dashed line below the name of the attribute. Then the relationship between two entity sets. So if many to many relationship is there, then we can represent like this, means simply the simple line between the relationship set and the entity set. If the many to one relationship is there, then the simple line to the many side of the entity and the arrow for or the directed line to the one side of the entity. And one-to-one relationship, if the one-to-one relationship is there, then we can use directed line to both sides. Then role name means if we have given any label to the line between relationship and the entity, then it is called as the role indicator. Then cardinality limits, okay, means low to high, low and high. So we can represent the cardinality limits between the relationship set and the entity set. Then this generalization, specialization, then disjoint generalization. Okay, so this part we will see later. But here the symbols are there, means if the generalization or the specialization concept is there, then we can represent it like this, means E1, E2, E3, these are the entity sets, and we can say E1 is the base class or the base entity set or the main entity set, and E2 and E3, these two are the sub entity sets, and we can represent generalization and specialization with the help of triangle symbol. So this triangle symbol is connected between E2 and E3, and again it is connected between E3 and E1. Okay, so this is a relationship. So this kind of relationship is called as the a relationship, and it is nothing but generalization and specialization. Okay, then these are the some alternative ER notations, means either we can use the notations that we have seen previously, or we can use the notations like this, means we can represent the entity and the attributes of that entity like this, means here the E is the entity set with the simple attribute A1, and the A1 is also the primary key. Then if the composite attribute is there, then here again A2 is the composite attribute, and again for the A2 some components are there, then we can draw two more attributes, that is A2.1 and A2.2. Then A3 A3 is my multi-valued attribute. So the multi-valued attribute, it is represented by double ellipse. Okay, simple attribute is represented by single ellipse, and the multi-valued attribute is represented by the double ellipse. And here A4 is my derived attribute. So this derived attribute is represented by dashed ellipse. Okay, so like this way also we can draw our ER diagram. Means here simply we can give the name of the entity set. Consider here the student. So in the student entity set, roll number is my primary key, and the roll number uh, is my simple attribute. Then I can write here in the ellipse the roll number and the underline to that roll number. And here the A2 is nothing but the student name is my composite attribute. Then I can write here the student name, and again here the first name, middle name, and one more ellipse and the last name. Then A3, suppose the phone number of the student, it is the multi-valued, then I can write here phone number, and the derived attribute, the age of the student. So I can use either this form or this form, means entity and the name of the attribute. Okay, we can use either of the forms or the either of the notations to draw the ER diagram. Then again, the many-to-many relationship, either we can represent it with the help of a simple line and the directed line, or we can represent it with the help of star and the one. Means if the many-to-many relationship is there, then we can represent it with the help of star. If it is one-to-one, then we can represent it with the help of one. Okay. Then again, the participation, total, and the partial. If the total is there, then we can draw double line, and if the partial is there, then we can draw a single line. Then the weak entity set, it is represented with the help of double rectangle. Okay, double rectangle is nothing but the weak entity set. Then generalization, it is represented by is a relationship in a triangle. Okay, now we will see what is exactly weak entity set. Okay, we have seen how to represent the weak entity set. Okay, and now we will see what is weak entity set. So simply think that, consider that the weak entity set is nothing but the particular entity set that does not have sufficient information or sufficient attribute to represent the information. It is called as the weak entity set. Okay, weak entity set means the entity set which does not have sufficient attributes to represent the information is called as the weak entity set. Okay, now consider here, it is the example of section and the course. So consider a section entity which is uniquely identified by a course ID, semester, year, and the section ID. Means the section is one entity, and the course ID, semester, year, and the section ID, these are the attributes of the section entity. Then the section entity are related to the course entities. Suppose we create the relationship set section course between the entity set section and the course. So here simply the section means, so in what year or what semester that particular course is there, that is that information is represented by the section entity. Now the information in the section course is redundant because the section already has the attribute course ID which identifies the course with which the section is related. Means what? Here the course ID attribute is the redundant attribute. Means this course ID attribute is present in the section entity, and the course ID attribute is also present in the course entity. Okay. And in the course entity, the course ID is the primary key. Okay. So one way to reduce this redundancy is that not to store the attribute course ID in the section entity, and to only store the remaining attributes like the section ID, year, and the semester. Means one way to reduce this redundancy is that the course ID attribute, we delete the course ID attribute from the section entity and we just keep the section ID, year, and the semester attribute. Okay, but the entity set section then does not have enough attributes to identify a particular section entity uniquely. Means if we remove or if we delete the course ID attribute from the section entity, then that section entity, it does not have the particular attributes or sufficient attributes to identify data uniquely. Means each section entity is the distinct, and the sections for the different courses may share the same section ID, year, and the semester. Means it is possible that in a single year, in a single semester, multiple courses are there. Okay, please consider for your third year first semester, total 5 to 6 courses are there. And if the course ID information is missing in the section entity, then we cannot uniquely identify every tuple. Okay, means the information in the section entity, it may be repeated. Means it may possible that for the 5 courses, the third year same one, third year same one. So this information is repeated 4 to 5 times if the course ID attribute is absent in the section. Okay. So then, so we consider the section course relationship as a special relationship that provides the extra information, and in this case, the course ID is required to identify section entities uniquely. Okay, so the course ID is required to identify which course or to identify that particular course is in which semester, in which year, etc. Okay, and this is denoted by the weak entity set. Means in our example, if the section entity does not have enough information or the section entity does not have the sufficient attributes to represent the information, then we call the section entity as a weak entity set. Because if the course ID attribute is not present in the section entity, then we cannot uniquely identify each and every tuple from the section entity. Okay, and if we provide or if we add course ID attribute in the section entity, then the data may be duplicated or there may be the redundancy in the section course relationship. So we consider this particular relationship as a weak entity set. Okay, so weak entity set means what? An entity set that does not have sufficient attributes to form a primary key is called as the weak entity set. Means in the weak entity set, the primary key is missing. We can say that. Okay, means in a particular entity set, if the particular or the sufficient attributes are not present to form a primary key, then that set is called entity set is called as the weak entity set. And an entity set that has a primary key, it is called as the strong entity set. Means in that entity set, we can assign a particular attribute as a primary key. Means that primary key, it describes the information of that entity set uniquely. So that entity set is called as the strong entity set. Then the weak entity set is the one whose existence is dependent on another entity set. Means always the weak entity set is depend on the another entity set, and that another entity set is called as the identifying entity set. Means weak entity set is dependent on the identifying entity set. Okay, and instead of associating a primary key with the weak entity set, we use the identifying entity along with the extra attribute called as the discriminator to uniquely identify a weak entity set. Means we cannot use the primary key with the weak entity set, but we know that the weak entity set is depend on the identifying entity set, and we can provide primary key to the identifying entity set, and that primary key or that attribute is called as the discriminator of the weak entity set, and this discriminator, it uniquely identify the weak entity set. Okay, understood what is exactly weak entity set means? So the weak entity set is nothing but the entity set that does not have sufficient attributes, or the entity set that does not have enough attributes to represent the information or to form a primary key. So it is called as the weak entity set, and always the weak entity set is dependent on another entity set, and that entity set is called as the identifying entity set, and we can use one attribute or the primary key with the identifying entity set, and that attribute is called as the discriminator of the weak entity set. Okay, so the every weak entity must be associated with identifying entity, means always the weak entity set is depend on or it is connected with the identifying entity. So that is the weak entity set is said to be existence dependent on the identifying entity set, because the weak entity set is always dependent on the identifying entity set. So we call it as a existence dependent on the identifying entity set. The identifying entity set is said to own the weak entity set that it identifies. Means we can say that the identifying entity set, it owns the weak entity set, and the relationship associating the weak entity set with the identifying entity set is called as the identifying relationship. Means the relationship between that weak entity set and identifying entity set is called as the identifying relationship. Okay. Now it is the expression of the weak entity set, means how to represent entities weak entity set in the ER diagram. So in the ER diagram, the weak entity set is depicted via a double rectangle. Means here in our example, the section is the weak entity set and it is represented by double rectangle. Okay, then we underline the discriminator of a weak entity set with a dashed line. So in the weak entity set, if we define some attributes, then that attributes, it is called as the discriminator, and all the discriminators are represented with the help of dashed line below the name of the discriminator. Then the relationship set containing the weak entity set to the identifying strong entity set, it is represented by the double diamond symbol. And here the primary key for the section, means if we form the primary key for the section, then we can include the primary key of the strong entity set first and then the discriminators of the weak entity set. Means here the primary key for the section includes course ID, section ID, semester and the year. So this whole set is nothing but the primary key for the weak entity set. Okay, so if the weak entity set, it does not have the primary key, then we can take the primary key from the strong entity set and combine that primary key with all the discriminator, and that particular group of attribute is act as a primary key for the weak entity set. Okay, so in our in the ER diagrams, we can represent the weak entity set with the help of double rectangle and the attributes of the weak entity set as a discriminator, means it is represented as dashed line below the name of the attribute, and the relationship is represented by double rectangle, double diamond symbol. Okay. Now It is the example of the university enterprise. ER diagram example for the university enterprise. Okay, so here this university enterprise, it is represented by the ER diagram, means it contains the department as an entity, then student as an entity, instructor as an entity. These are the attributes of the entity. Then between the instructor and the student, the advisor relationship is there. Okay, and between the department and the student, again the student department relationship is there. And here between the instructor and the department, ins department relationship is there. Then here we have added some mapping cardinalities. Okay, if we consider from instructor to the student, so it is one to many relationship. Then here the total participation is also represented between the student and the department relationship. Then here the section entity set is there, and we know that the section entity is the weak entity set, so it is represented by double rectangle. Then this with the section entity, again the classroom entity is there, then course entity is there, and time slot entity is there. Okay, and the relationship between every entity. So if we have to represent the ER diagram, or if we have to draw the ER diagram for any application, then we have to include all the notations of the ER diagram. Means the entity sets are required, relationships are required, then mapping cardinality we have to include, attributes we have to include, and that total and the partial participation, means participation also we have to include in our ER diagram. Okay, so it is the example of the university enterprise. Now there is a homework for you people, that you have to draw the ER diagram for let's take example of same example, company management or the employee management. Okay, so you have to draw the ER diagram for the company. Okay, consider any company, means XYZ, and in that company you have to consider how many entities will be there, then what will be the attributes, then what will be the relationship between the entities. Okay, so we have to consider all the things. Okay, simply there may be one entity as a company, then there may be one entity as the department, employee it is the another entity, or what is the another, the time slot, we can include also time slot. If the shifts are there in the company, then we can also include the time slot, etc. Okay, so your homework is that you have to draw the ER diagram for the company management. Understood everybody? Okay, yesterday I will ask this. Now this ER diagram part is over. Now we will move towards our next point, that is reduction to relation schema. Okay, so this reduction to relation schema means what? When our ER diagram is ready, means our design part is ready. Now we have to reduce, or we have to convert the ER diagram into the relational schema. That is nothing but reduction to the relation schema. Means suppose we have drawn ER diagram that contains entity sets, relationship set, then some participation, if the weak entity set is there, then different attributes, then we have to translate these notations or these diagrams into the relational schema. So how to transfer or how to convert into the relational schema, that we will see in this point, that is reduction to relation schema. So this the entity set and the relationship set can be expressed uniformly as the relation schema that represent the contents of the database. Means especially the entity set and the relationship set, they are expressed in the relation schema. Then A database which conforms to an ER diagram can be represented by a collection of schema. For each entity set and the relationship set, there is a unique schema that is assigned the name of the corresponding entity set or the relationship set. Means, suppose in our ER diagram, we have drawn one entity set, consider employee, and the relationship set, consider what employee department. Okay, so it is the relationship set. Then we can convert that entity set and the relationship set into a unique schema, and we can give the name of the entity set to the name of that schema or to the name of that table. Okay, so each entity set and the relationship set, there is a unique schema that is assigned the name of the corresponding entity set or the relationship set. Means we can directly assign the name of the entity set to the name of the table. Means if in my diagram the employee entity set is there, then in my database I can give name of the table as a employee. Okay, if the relationship is the inst department or the employee department is there, then I can give directly the employee department as a name to the table. Then each schema has a number of columns, okay, which have unique names. Okay, so these columns are nothing but attributes in the ER diagram or the attributes of the entity sets. So we can give name of the attribute of the entity set to the name of the columns. Okay, so the attributes are corresponding to the column names. Then the first point is how to represent the entity set in the relational schema. So if the strong entity set is there, then the strong entity set reduces to a schema with the same attribute. Means if the strong entity set is there that having the primary key, then directly we can reduce it to the schema, that is name of the entity set as a name of the table. Means like this, student, then ID, name and total credit, these are the attributes of that student entity set. So we can directly give these attributes to the student schema, student table, and if the ID is my primary key, then I can give or I can write the primary key as a underline to that attribute. Okay, means after our ER diagrams are ready, then next step is we have to reduce that ER diagram to the relational schema. And for converting that ER diagram to the relational schema, just we have to use the names of the entity sets, relationship set, and the attributes. Okay, and if the weak entity set is there, then the weak entity set becomes the table that includes the column or the primary key of the identifying strong entity set. Means if the weak entity set is there, and while creating the relational schema, we can write the name of the weak entity set as it is, that is section, and we can include the primary key of the strong entity set into that into the schema. Means here we can use the course ID, which is the primary key of the course, and comma section ID, semester, and the year, and we can make the whole set as a primary key. Okay, so this whole set is nothing but the primary key, and it is called as the composite primary key. Means if the particular key contains more than one primary key, then it is called as the composite primary key. So if the weak entity set is present in the ER diagram, then while reducing that weak entity set to the relational schema, first we have to write name of the weak entity set as it is, and then we have to use the primary key of the identifying or the strong entity set, and then we have to use, and we can take the names of the attributes of the weak entity set as it is. Then the representation of the entity set with composite attribute. Okay, so we know that these are the composite attribute, means name, address, etc. So the composite attributes are represented by creating a separate attribute for each component attribute, because in the database we cannot create such kind of hierarchy while creating the table or while creating the schema. So the solution is we have to use separate attribute for this first name, middle name, and the last name. Okay, if we are reducing such kinds of attributes to the relational schema, then we have to make a separate entry or separate attribute for each and every component attribute. Okay, um, then the next one is the representation of entity set with the multi-valued attribute. Means if the multi-valued attribute is present in the entity set, then that multi-valued attribute M of the entity set E is represented by the separate schema EM. Means if the multi-valued attribute is present in the is present in the entity set, then while reducing it to the relational schema, we can directly create the new schema for the multi-valued attribute. The schema EM has the attributes corresponding to the primary key of the E, means that new schema, it contains the attributes, that is the primary key of that entity set and the attribute corresponding to multi-valued attribute M. Means the multi-valued attribute is also the attribute of that new entity set plus the new primary key of that entity set. Consider example, the multi-valued attribute phone number of the instructor is represented by the schema. Okay, we know that, means consider here the phone number is the multi-valued attribute of the instructor entity set. Now, while reducing it to the schema, we create the new schema or the new table of the inst phone. Okay, means we can give the name of that multi-valued attribute as a new schema, and this new schema contains the two attributes. The first attribute is the primary key of this schema and the multi-valued attribute of the entity, that is the phone number. Okay, so if the multi-valued attribute is present in the entity set, then while reducing it to the relational schema, we have to make a new schema or we have to make a new table, and we can give name of that table as the name of the multi-valued attribute, same as the multi-valued attribute, and we have to include minimum two attributes. Okay, so the first attribute must be the primary key of that new schema, and another attribute is nothing but the multi-valued attribute of the entity set. So each value of the multi-valued attribute maps to a separate tuple of the relation schema relation on the schema EM. Means if an instructor is having 2 or 3 phone numbers, then we can add all the phone numbers in this new schema. Okay, but if we have not created this new schema, then we can add only one phone number of the instructor. Okay, because we can store only one value in the database while creating the database. But if we have created new schema or the new table for the multi-valued attribute, then we can add all the values of that attribute into that new table. Then next one is the representing the relationship set. Okay, if the relationships are present in the ER diagram, then how to reduce that relationship set. So a many-to-many relationship set is represented as a schema with the attributes for the primary key of the two participating entity sets and any descriptive attribute of the relationship set. Means if there is a many-to-many relationship between the two entity set, then we can create a new schema and we can give the name of that schema as a name of the relationship set, means here the advisor. So here the advisor is our new schema, and for this new schema we can give attributes. So what are the attributes? So these attributes are nothing but the primary key of every entity which is present or which is involved in that relationship. So here only two entities are involved, that is student and the instructor. So here we can include SID as a student ID, and it is the primary key of the student, and we can include IID, that is the ID of the instructor, and it is also the primary key of the instructor. So the advisor relation or advisor schema, it contains two attributes, and that is nothing but the primary key of both entity sets. If the many to many relationship is there, then we can add the primary key of two entity sets as a attribute of the schema. Now next point is the design issue. Okay, means these are the issues or the design issues related to the ER model. Means while drawing the ER model, we think that, or there may be the case that where to use entity set or where to use the attribute, or it is feasible to use entity set or it is feasible to use the relationship set. Then or it is feasible to use the binary relationship, or it is feasible to use the ternary relationship. Okay, so such kinds of problems are there, or we can say that these are the some design issues of the ER diagram. Now very first issue of the ER diagram is use of entity set versus attribute. Okay, means consider here the instructor entity set with the phone number as the attribute. Okay, and we know that the phone number is our multi-valued attribute. Okay, so we can use the use of the phone as an entity allows extra information about the phone number, plus it allows the multiple phone numbers. Means the instructor, it is one entity set, and the phone number is one attribute of the entity set instructor. So instead of using phone number as an attribute, if we create the phone number as a new entity set, then it will allow us to store the extra information about the phone. Okay, so it is our first issue. Means either we can use the entity set or we can use the attribute in the entity set. Okay, means here in the instructor entity set, the ID, name, salary and phone number, these are the attributes. And the phone number, we can keep the phone number as a one attribute for the instructor entity set. But if we keep like this only, then we cannot add more than one phone number of that instructor if all the instructors are having 2 or 3 phone numbers. But here we can save only one phone number if we are using the first schema. Okay, that is instructor entity set. But instead of this, if we create the new schema or if we create the new entity set of the phone number like the phone, and if we add the attributes as a phone number and the location, or we can add the extra information as the phone number, location and the phone type, means whether it is landline or whether it is mobile, etc. So if we create the new entity set as a phone number, then if we use the inst phone as a relationship between instructor and the phone number, then also we can use information of the instructor and the phone number simultaneously. So there are two options: either use attribute, means either use the entity set and its attribute, or another option is make new entity set of the particular attribute. Okay, if we make a new if we made a new entity set, then it will allow us to add extra information about that entity set. Okay, means we can add the phone number, location, etc. Okay, then another another mistake or the another issue is that a common mistake is to use the primary key of an entity set as an attribute of another entity set instead of using a relationship. Means, so consider this figure A. So in the figure A, two entity sets are there, student and the instructor. And here attributes of the student are SID, name and date of birth, and attributes of instructor are instructor ID, name, salary and SID. Okay, means what? Here, if this instructor is teaching or instructor is advising something to the student, then it is not necessary to add the primary key of the student entity into the instructor entity. Means here we are using the primary key of the one entity set to the attribute of the another entity set. So instead of using this, we can create the relationship between the two entity set. Means it is incorrect that to model the ID of the student as the attribute of the instructor. Means it is not necessary to give primary key of one relation, primary key of one entity set as a attribute of another entity set. So instead of this, we can create the advisor relationship. So the relationship advisor is the correct way to represent the connection between student and the instructor, since it makes their connection explicit rather than implicit via the attribute. So if we use the primary key of the one entity set as a attribute to the second entity set, so relation is there or the connection is there between these two entity set, but this relation or this connection is the implicit. So instead of using implicit relationship, we can use the explicit relationship. Means we can add one relationship set between the student and the instructor, so that we can avoid this SID attribute in the instructor. So we just create one relationship between the student and the instructor. Okay, so it is the first issue, means entity set versus attribute. Now the second issue is use of entity versus relationship set. Means whether to use entity set or to use the relationship set. So here the text relationship set, it is used to model the situation where a student takes a course. Means here the student takes a section of a course. Means the course is present in one of the section, or the course is present in one of the semester or one of the year, and student takes that particular course. Okay, so instead of using this, the alternative solution is use the course registration record for each course that each student takes. Means instead of that text relation, we can use here the course registration entity set. Means instead of that relationship set, we can use here the entity set, that is the course registration. So this registration entity, it is related to exactly one student and it is related to exactly one section. So we have two relationship set here. Means one relationship set is section registration between section and the course registration, and another relationship is student registration between the registration and the student. Okay, so in our in this diagram, means in this figure here, we have used the text as a relationship. Okay, which text means the student takes the course of a particular section. Okay, so we can represent this relationship in this way. But instead of this text relationship, suppose we are using the course registration entity, then with the help of this diagram, we can show that for a particular course registration, there is a single course. Means a single student can register a particular course, and that particular course, it is from a particular section. And to represent this relationship, we can use here two more relationship. That is, first is the section registration between the section and the registration entity, and another one is the student registration between the student and the registration entity. Okay, so that takes relationship set, it is replaced by one entity set and two relationship set. Okay, means here we have replaced the relationship set by the entity set and more relationship set. So the registration, course registration, it is the entity set that representing course registration record. Then section registration, it is the relationship set that representing the registration and the course. Means it shows the relation between registration and the course. And the student registration, it is the relationship set relating the registration and the student. Means we can use either entity set, or we can use the relationship set, or we can replace relationship set by the entity set. Okay, means with the help of this, we can represent our information very clearly. So we can use either of them. Means either we can use entity set or the relationship set. Then the third one is the binary versus non-binary relationship. Okay, so the binary relationship means the relationship between the two entity sets, and the non-binary means what? The relationship between two or three entity sets. So it is possible that we can replace the non-binary relationship set by the number of different binary relationship. Okay, means if there is a ternary relationship, means the relationship that involve three entity set. So we can replace this ternary relationship by the binary relationship, and for this purpose we can use number of binary relationship. Okay, so consider here the ternary relationship, that is n is equal to 3, means number of entities are 3, and relating sets A, B and C, means R is the ternary relationship and A, B, C, these are the entity sets. So here we replace the relationship set R by the entity set E. Okay, let's see in the figure B. So here this relation R is replaced by entity E. Means instead of relation R, we can use the entity. Okay, we have seen that. So this instead of R, we can use the entity set E, and again between this new entity set and the old entity set A, we can add a new relationship. Consider RA. So it is the binary relationship. Again, we can add the relationship between the new entity set E and the old entity set C, that is RC is the relationship, and RB is the relationship between B and E. Okay, so we can create the three relationship sets. So RA, that is relating to E and A, RB, that is relating to B and E, and RC relating to E and C. Means if the ternary relationship is present in the ER diagram, then we can replace it with the help of number of binary relationship set. Okay, so for this purpose we have to just replace that relationship with the new entity set, and then we have to add the new relationship set between the new entity set and the old entity set. Then if the relationship set R had any attributes, okay, means if the relationship set R had some attributes, then these are assigned to the entity set E. Okay, we know that we can give attributes to the relationship set, and if we replace the relationship set by the entity set, then we can directly give that attribute to the entity set. And for each relationship AI, BI, CI in the relationship set R, we create a new entity EI in the entity set E. Means AI, BI, CI, we can say these are the what we can say, these are the attributes, and we can also insert a new attribute of the E, that is EI. Then in each of the three new relationship set, we insert a relationship as follow, that is EI and AI in the RA. Means we can give the relationship RA, we can give attribute EI and AI. We can give, or we can add the attributes EI and BI to the relationship RB, and we can add the attributes EI and CI to the relationship RC. Okay, so like this way we can represent the binary relationship between, or we can replace the ternary relationship or the non-binary relationship by the binary relationship. Okay, now the next point is extended ER features. Okay, I think it is the last point in your ER model. Okay, miss, the first part of your second chapter. So the extended ER features, there are total three ER features. The first one is the specialization, next one is the generalization, and the last one is the aggregation. Okay, so the specialization, generalization, they are similar to your inheritance concept. Okay, means inheritance you have seen in the C++ or in the Java also. So inheritance means one base class is there, or one parent class is there, and number of child classes are there, and every child class is inheriting some data from its base class, and the child class is also have its own data or own attributes. So the specialization and the generalization, these are same as your inheritance. So the specialization is nothing but it is the process of designating the subgroupings within the entity set, that is called as the specialization. Means the specialization is the top-down design process. Means we are moving from top entity set to the bottom entity set. So it is called as the top-down design process. Means we are going in a deep of the entity set. Means we are finding something special into the entity set. That is nothing but the specialization, or it is the top-down process. So in the specialization, we designate the subgroupings within an entity set that are distinctive from the other entity set. Means in the specialization, we are moving from top to bottom or top to down, and we are finding the subgroupings of a single entity set. That is nothing but the specialization. And these subgroupings becomes the lower level entity set. Means one high level entity set is there, and we are dividing that high level entity set to create some low level entity set. The specialization relationship, it is represented by the triangle component labeled as a ESA. That is nothing but is a. Okay, meaning of ISA is nothing but is a. Means what? The instructor is a person. We can say that. Okay. So here the person is our higher level entity. Okay. Person means instructor is a person, student is also person, then teacher is also person, manager is also person. Means what? The instructor, teacher, manager, student, these are some special classes of the person. Okay, so the specialization means we are creating the subgroupings of the higher level, that is we are creating the subgroupings of the person, and these subgroupings are nothing but instructor, teacher, manager, etc. Okay, and it is represented in the ER diagram by the triangle component that is called as the is a. Then the specialization relationship, it is also called as the superclass and subclass relationship. Here the superclass means the class which is present at the higher level, and the subclass means the class which is present at the lower level. Now in our example, the person is the superclass, and the instructor or the student. These are the subclasses. Okay. So in the specialization, we can use the attribute inheritance. So the attribute inheritance means a lower level entity set inherits all the attributes and the relationship participation of the higher level entity set to which it is linked. So in the attribute inheritance also, uh, we can we can inherit the attributes of the higher level entity set. Means the lower level entity set, it is having its own attribute, plus it inherits the attributes of the higher level entity set. So that is nothing but the attribute inheritance. Okay, means for example, consider for the person entity set, two attributes are there: person ID and address of the person. Okay, these two are the attributes of the person. And for the instructor, the name of the instructor and the phone number of the instructor. Suppose these two attributes are there. And if we use the attribute inheritance, means what? For the instructor entity set, there will be four attributes. Okay, four attributes means two attributes of the instructor itself, that is name of the instructor and the phone number of the instructor, plus it inherits the attributes of the person person entity set, that is the ID of the person and the address of the person. So the attribute inheritance means what? We can use the attributes of the higher level entity set or attributes of the higher class into the lower level entity set. It is the example of the specialization. So in the specialization, we are using overlapping and disjoint. Okay, so the overlapping is nothing but an entity may belong to multiple specialized entity set, that is called as the overlapping. Here, example of overlapping is employee and the student. Means the entity, it is belong to multiple specialized entity set. So here the example is the employee and the student, and the disjoint is nothing but the entity must belong to at most one specialized entity set. For example, instructor and the secretary. Okay, so the instructor and the secretary, they are they are inheriting the data from the employee, so it is called as the disjoint. And overlapping means if the entity is belonging to multiple entity sets, then it is called as the overlapping. Okay, so it is the example of the specialization. Specialization, it is represented by the triangle symbol, which is connected between the base class or the super class and the subclasses. So here the person is the main class, and employee and the student, these two are the subclasses of the person. Okay, and so we can add here this triangle symbol. So it is the specialization. Now the next one is the generalization. So the generalization, it is opposite of the specialization. That is, the generalization is nothing but the bottom up design process. Okay, means in the generalization, we combine a number of entity sets that share the same features into the higher level entity set. Means in the generalization, we are moving from bottom to top. Okay, means we are first considering the lower level entity sets, and then by combining these lower level entity sets, we are reaching to the higher level entity set. So the generalization is nothing but it is the containment of the relationship that exists between higher level entity set and one or more lower level entity set. Okay, means it is, we can say that it is same as the specialization, but the main difference is that in the specialization we are moving from top to bottom, and in the generalization we are moving from bottom to top. Both are performing the concept of inheritance, means both are inheriting their data Okay, but the difference is top to bottom and bottom to top. Then the attributes of the higher and the lower entity sets are the common attributes. So this commonality is expressed by the generalization. Okay, generalization means moving or going in a very general way. Okay, or if I want to find out a specific thing, a general thing, then I can use the generalization. And here the attributes are same, means attributes of the lower level entity and the higher level entity, they are same. The specialization and the generalization are the simple inversions of the each other, means they are opposite of each other, and they are represented in a ER diagram in the same way. Means with the help of is a relationship, both generalization and specializations are used. The terms specialization and generalization are used interchangeably, means both are working same, or the concept of generalization and specialization are same, so we can use either of them. And the last ER feature is the aggregation. Okay, simply the aggregation is nothing but we can represent the relationship between the relationship. It is called as the aggregation. Okay, so the aggregation, consider here the ternary relationship is there, that is the project guide. Okay, so this project guide is the ternary relationship between the project instructor and the student. Okay, suppose that if we want to record the evaluations of the student by a guide on a project, means suppose the evaluation entity set is there, and that particular guide, it evaluates the project of the student, and he give report accordingly. Suppose we have to record this information. Then the relationship set, evaluation for, and the project guide represent the overlapping information. Means what? The project guide, it also uses the instructor project and the student data, and the evaluation for this relationship, it also uses the instructor project and the student data. Means the instructor is evaluating project of the student, means these two relationships, they are using the same entity sets, or we can say that there is overlapping between these two entity sets. And the every evaluation for relationship corresponds to a project guide relationship, means both are same, and some project guide relationship may not correspond to any evaluation for relationship. Means what? It is possible that some project guide or some guide, they are not evaluating the student's project. It is possible that, so we have to eliminate this redundancy via the aggregation. Means here the evaluation and the project guide, they are using the same information. Means what? The redundancy is there between these two relationships. So we can remove this redundancy with the help of aggregation. So while applying the aggregation, means what? It treat the relationship as a abstract entity. Means it consider the one relationship set as a entity, and allows relationships between the relationship. So simply the aggregation is nothing but it is the relationship between the relationship. Okay, means we can represent the relationship between two relationship set with the help of aggregation. So it is the abstraction of relationship into the new entity. Means while eliminating the redundancy with the help of aggregation, we can consider one of the relationship as a entity set. Okay, so here while eliminating the redundancy with the help of aggregation, so here the student is guided by a particular instructor on a particular project. So we consider this particular relationship as a entity set. Means this project guide relationship, we can consider it as a entity set, and again we can represent the relationship evaluation for between the evaluation entity set and this whole entity set. So the student, instructor and the project combination may have an associated evaluation, because for doing evaluation of the project, again we require student, project and instructor entity. Okay, so we can eliminate such redundancy with the help of aggregation. Means if such concepts or such cases are there, then we have to make one relationship set as a entity set, and then we can consider the relationship between the old entity set and this new entity set. So simply the aggregation is nothing but it is the abstraction through which the relationship set are treated as a higher level entity. Means in the aggregation we consider the relationship set as a particular entity. Okay, so these are means the specialization, generalization, and the aggregation. These are some special or the advanced topics of the ER diagram. Okay, so this ends. Okay, so this ends our last part, the first part of our second chapter, that is ER model. Okay, so in our next lecture, which is in tomorrow, we will see the second part of the second chapter, that is relational model. Okay, and remember tomorrow there will be MCQ test on first chapter. Okay, so at least read some PPTs of the first chapter, and tomorrow I think I have given you one homework also. Okay, you have to draw the ER diagram for the company management or the company database. Understood? Okay, so we'll stop here today. Now give me presentee. Call your numbers.
1.
Next.